playing basketball, Jan makes four, or that might be Jan. I guess it depends where you're at. Jan makes four out of every 10 shots she takes. Select all the statements that describe Jan's situation. Okay, first thing I'm noticing is before I even start reading these options, it says select all. And I know that when I get a select all problem, I can't just solve something up here and then choose one or even a few. I need to solve every single one to see what it comes out to. Okay, and then I can make my selections. All right, so Jan makes four out of every 10 shots she takes. Okay, so she makes 4 out of 10. Let's read this first option. The ratio, and I'm going to label this actually. This is what she makes, and this is what she shoots. Okay, she shoots 10 total, four of those she makes. All right, the ratio of the number of shots Jan makes to the number of shots she takes is 2 to 5. When you convert this 2 to 5 in the way it's written here to like a fraction, it's the first numbers on top and the second numbers on bottom. So it'd be like this. So 2 to 5 would be a fraction type ratio as 2 over 5. Okay, no problem. So basically, we're just asking, hey, is 4 over 10 equal to 2 over 5? And to simplify this fraction, you just list the common factors. You list the factors of each number. So 1, 4, because 1 times 4, and then 2 times 2. So we got 1, 2, and 4. All right, for 10, we got 1, 10, 10, 2, and 5. And I can see the greatest common factor here is 2. So now dividing both sides, rather dividing the top by 2 and the bottom by 2, we get 4 divided by 2 is 2, 10 divided by 2 is 5. And so we see that this is correct. Let's go to the next one. The ratio of the number of shots Jan makes to the number of shots she does not make is 2 to 3. Okay, this is interesting because this is a different ratio than what's specified here. This is Jan makes 4 out of every 10 she takes. This is a different thing. This is comparing shots made to shots missed. So we need to go back to our original situation here and make a new ratio, right? This is how much she makes. This is the total basketball shots, okay? This ratio is saying shots made to shots she does not make. So in this scenario, if she makes 4, she does not make 6. So using this information, we're going to make a new ratio of shots made, shots she makes, over shots she misses, which must be 6, right? If there's 10 total shots and she makes 4, that means she missed 6 of them. Okay, so this is from our original situation, 4 out of 6. And let's see what they're claiming now. The ratio of the number of shots Jan does not make, the ratio of the number of shots Jan makes to the number of shots she does not make is 2 over 3, which corresponds to a fraction of 2 over 3. 2 to 3 is 2 over 3. Okay. Well, let's find out if we can simplify 4 over 6 to 2 over 3. Our factors of 4 are 4, 1, and 2. Our factors of 6 are 1, 6, 3, and 2. So we have a greatest common factor of 2 here. 4 divided by 2, 6 divided by 2. We're scaling the fraction down to find a more simple equivalent fraction, which is 2 over 3. And so we see that this actually is correct. Important things here is making sure my order is correct. First number is on top here, right? And reading carefully what they're describing the ratio as. All right, let's continue. The equation 4x equals 10y shows the proportional relationship between x, the number of shots Jan makes, and y, the number of shots she takes. Okay, what I would do at this point is they're asking me for an equation. Before I even read this and start checking it, I'm just going to find the equation that I would use based on the variables they assigned, and just get my answer. And then once I'm done, see if this is correct. That's going to make it less likely for me to make an error as I'm just working backwards from their answer. I'm going to see what I actually get from the ground up. All right. So if we have back on our original ratio from this top part, 4 shots made out of 10 total shots taken. And they have specified specifically that X is going to be the number of shots she makes. Okay, so this is interesting. Notice that I had to read this really carefully because if I made this my K value, I would be implying that the shots made are Y because it's Y over X. Whereas in this problem, the shots made, they have specified that they want it to be X. Okay, so I'm going to flip this around because it's always Y over X for my K value, which we need in order to set up our ratio, or our equation rather. So I'm going to say our Y is the number of shots taken. So this is Y, shots taken. This is X, shots made. Okay. And now it's just a matter of plugging this in, Y equals KX. So we have Y equals 10 over 4X. Now clearly this equation does not look like this. But we need to take one more step because it is possible that these are equal. They did something a little different here where they, you could say, resolved this fraction, and we need to see if this could be actually equal. So I can see that this side of the equation, or actually rather over here, they kind of like put the 10 on one side and the 4 on the other. So let me see if I can do something to try to get this to look like that, because it doesn't look like it yet, but there still might be a way. Make some more space here. Okay. Well, one thing I could do is I could multiply both sides by 4, and that would put 10 on one side and 4 on the other. So I'm going to go ahead and do that. Times 4, that cancels, and then times 4 over here. So now that leaves me with 4y equals 10x. And I see that this is really like the opposite of this equation, right? It's 4y equals 10x, not 4x equals 10y. And I landed at this based on very carefully looking at the values they assigned for the variables and making sure that x represents the number of shots she makes and y represents the number of shots that are taken. Okay, so this is going to be false. The other way I could also check is just plug a value in, or a pair rather, plug in a pair and see if it comes out to be a true statement, right? That's another way we could do it. When we get an equation where it doesn't look like we're used to, okay? 4x equals 10y. Let's plug in our value for x, which they have specified is the number of shots she makes. So in this situation, it would be 4. So let's write the equation they gave us in the problem. In this possible answer choice. And let's see if it comes out to be true. If it does, that means I did something wrong in this last step. If it doesn't, that further confirms that this is not a true statement. All right, so we'll use a pair to evaluate whether this is true. 4 for the shots made, and we plug that in for x. So 4, notice how I'm substituting in the value. It's replacing the x. The x is a placeholder for a specific number of shots that she makes, okay? And then 10, and let's plug in our y value associated with that, which is shots she takes. Let me make sure I did that right. Y, the number of shots she takes, okay, which is 10. And let's see if these come out to be equal. This side, 4 times 4 is 16. equals 100. This is not true, right? So that equation will not lead to this pairing, so this is not correct. Okay, last one. I'm going to make some more space here. All right. Ooh. Okay, last one here. The equation 6x equals 4z shows the relationship between x, the number of shots Jan makes. So they're saying x is the number of shots she makes, and z, the number of shots she does not make. Does not make. Okay, based on how we did this last problem, I think the second way I did it was a lot easier. I just plugged in a pair and saw if each side came out to be equal and used that to assess if it was true or not true. Okay, so I'm just going to use my pairing from before. Let's go back up to the original. Instead of using 4 and 10, because in situations where I asked for shots made out of shots taken, we need to use 4 for the shots made and 6 for the shots she does not make. Okay, so it's going to be, we're going to use our pair of 4 for x, and then for z here, in this case, for z, it's going to be 6. Because if she makes 4 out of 10, that means she misses 6 out of 10. And I have to use the values they've specified in order to see if this equation is true or not. Okay, so for x, I'm going to substitute in 4. So 6, and wherever there's an x, I replace it with a 4. Notice how when I do this, the x is not there anymore. When you substitute a value in, it is being replaced, okay? The x is a placeholder for a specific shot made, a specific number of shots made. 4, and then we plug in, for z, we plug in 6. 6 times 4 is 24, and 4 times 6 is 24. This is true. That means this pairing would result from this equation, right? Another way you could show this, if that's in any way like seems strange to you, I could also go like this. 6x, so we already know this is true. This is just advanced if you want to continue watching. 6x equals 4z. I could also just substitute in the x value for shots made and solve for z, and I should get 6 if this equation would correctly predict this ratio. Okay, so again, this is shots that are made, and they specified that z is shots that are missed. So I'm going to plug in 4 for shots made, and z should come out to be 6. So let's find out. 6, plug in 4, or substitute 4 for x. We're going to solve for z. Whoops. So that's 24. 6 times 4 is 24 equals 4z. Divide both sides by 4. And we have 6 equals z. So that also confirms that this is correct. So the first two and the last one were true. This one